All right, 1-7, distributive property. Like I said before, this gets done wrong a lot. And I honestly don't. I did. Yep, she already said it to me. But thank you. That's why I said you're the best, because you guys are so good at reminding me. The distributive property, okay, is one that gets done wrong at the Algebra 2 level. So this is 2 years from now for you guys. It gets done wrong so often, and I swear it is not because the property is so difficult. It is because you work too quickly. So I need you to slow your brain down and take your time when you distribute things, because I know people know what they're supposed to do, but then they don't do it. Okay, so slow your brain down on these. You've got this. So this first one is just the general rule that goes along with it. If you have A times B plus C, what's happening is you are distributing this A. That A is being multiplied by both pieces, okay? So you are going A times B and A times C. What goes between them is whatever sign was between the original, okay? So that's a plus, so you're gonna make it a plus. What you are doing then turn your Wi-Fi on, all y'all. So what you're doing from here then is if they put the C at the back end as the thing that should be getting multiplied, same thing. You're taking the C times the A, AC, the C times the B, BC. If you wrote it CA, CB, it would be the same thing. But you're still adding, okay? If this was a minus in between, A times B minus C, then it would be AB minus AC, okay? Has anyone never seen the distributive property before? No, because I already showed you this one, right? But prior to that, did any of you never do the distributive property? Okay, that's great. I love that. Gwen, will you turn your Wi-Fi on? Or your Bluetooth, sorry. Your Wi-Fi is on. Turn your Bluetooth on. Okay, so this says simplify the expression. All you're doing here is distributing. So what is this going to become?
3x
Plus 8 times 3 is 24. Okay, you're done. Why do we not add those together? We're simplifying. They are not what? Like terms. Okay, we're going to talk more about like terms in a little bit, but those are not like terms. Therefore, you cannot add them together. It's like saying 3 apples plus 24 oranges is 27 apple oranges. That's not a thing, right? So if they have the same variables attached, then you may add them. But when they don't, you cannot, and you're just done. This is your answer. Okay, so look at letter B. What do you do?
-7 times 5b.
Yes, okay. Now, a -7 times 5b is what? -35, and you just keep the variable, -35b. Okay, what about this then? It's positive. This is a -7 times a -4 is a positive 28. Okay, now you could have said minus a negative and then turned it into plus a positive. If you like that step, that's fine. But please take your time. Just take your time. You can do it. I'm going to skip C. You guys are good with that. Look at D. Start with 12 times 3, which is 36. Now, the fraction. 1/6t times 12 is? Right, you're going to go minus 2 times t, right? It's 12 times 1/6, or if you want to treat it as a -1/6, you could. When you multiply that, 12 over 1 and 1 over 6 would cross reduce to 2 over 1, and then you could multiply across 2t, okay? Which we're subtracting, so minus 2t. Questions on that? Okay. I'm going to skip E also. That's just, you're going to get decimals, but you can plug that into your calculator. 0.4 times 3, 1.1 times 3, and you would get what you get. Look at letter F. You have 2y minus 1 times a -y. What are you distributing? A -y. What's another way to say -y? negative 1y, okay? So if you like it better with the number out in front, you could call it that. It's the same thing. But you are distributing it to both pieces. So what is 2y times negative y?
Negative 2y.
Negative 2y.
Negative 2y squared.
Y times y. Think of it like this. Okay, y plus y is 2y, right? But y times y, when you multiply a y times itself, you're squaring it. When you multiply a 3 times itself, you're squaring it, right? So y times y is y squared. So be careful here, because this is a very simple one to make a mistake on. This is like a negative 1y times 2y. So that's a negative 2y squared. Okay, y times itself is y squared. Okay, then
Plus.
go to the next piece. Negative y times a negative 1
Plus. Y.
plus y. That is 1y, right? So it's a negative 1 times a negative 1y, if you will. A negative times a negative is a positive. 1 times 1 is 1, and you're multiplying by a y. So it's really just a positive 1y. Now, if you want to put the 1 in, it's fine. You don't need to, okay? So negative 2y squared plus y would be your setup. Questions on that? Okay. Then take a look at this. Example 2, it says rewrite your fractional expression. What is the sum or difference equivalent to the expression that you see? Here's the deal. If you are dividing by 5, you are dividing everything by 5, right? So what we're going to do is we're just going to break it into what that looks like, but as the distributive property using multiplication. So instead of calling this dividing by 5 because it's ugly and 7 doesn't divide by 5 nicely, instead what we do is we treat this, it's a denominator, right? We're going to take that denominator and put it out in front as a fraction. We're going to call it 1/5, okay? Because essentially this whole thing, if you wanted to multiply it by something, it would have to be by 1. So we're going to put a 1/5 out in front, and then we're left with 7x plus 2. Now if you were to distribute that, you would go like this, and it would be 7/5 times x plus 2/5. Now, did I really have to go through this process to write that fraction out in front? No, because what I really did was I put this as a fraction and this as a fraction with the same symbol in between. Okay, so if it works out that way and you would prefer to do it that way, go for it. If you prefer to set it up as the distributive property, go for that, okay? But I'm telling you, it will work either way. You may set it up like this first and then distribute it, or you may just set them both up as a fraction and simplify, okay? I'm gonna skip B right now, and I'm gonna go on to C. You've got options. If you wanna call it 1/12 and put the 1/12 out in front, by all means, go for it. But what happens is we are just dividing everything by 12. So if we do that, okay, if I make this one fraction, 15/12, am I adding or subtracting here? We're adding because this is addition. And then we're gonna do this fraction because everything must be divided by 12. So plus 6x/12. Now that x, if you want, it can go behind the fraction or it can go in your numerator. I don't care, and you may do either way. So whatever makes more sense to you, run with it, okay? Is this the most simplified version of this expression?
No.
How would you come up with a more simplified version?
1/1, we have 12.
What?
1/2. It's 15/12 plus 1.
Okay, so you do get a 1/2. Here's the thing, guys. The reason we don't leave it like this is because you can reduce, and they might not reduce the same amount, right? Shane,
Can you make it 1/2?
you can make what 1/2?
The 6 and 12.
The 6 and 12 you can make 1/2.
The 15 over 12, 1 and 3.
Not 1 and 3.
1 over 10.
No, that would be 1/2.
Oh, 1/4.
No,
5/4.
5/4, right? You have to look at what is it divisible by. 15 and 12 are both divisible by 3, right? So you want to reduce by the same amount on both. Divide by 3, divide by 3. So 15 over 12 becomes 5 over 4, okay? Think about it this way, you guys. If your top number is the bigger number and your bottom number is smaller, when you reduce the fraction, it should stay that way. Your top number is bigger than your small number. So if you flip that and you get a smaller number on top, you did something wrong, okay? So this is 5/4 plus, and then this one, 6 and 12, if you divide by 6 and divide by 6, you get 1 and 2 with your x. So you can call it 5/4 plus x over 2. You can call it 5/4 plus 1/2 x and put the x out behind. I don't care which one you do, or you can ditch the 1 on the top one and just call it x over 2. That's fine too. Yeah.
So then we don't make them mixed numbers, so we went to
Yeah, just leave it as an improper fraction. Would be the preference anyway. Okay, so using that idea, look at letter D here. If we're gonna break that up, what are our two fractions to start? Don't simplify anything yet.
4 over 8 minus 2 over 8.
4 over 8 minus 2x over 8. Okay, what does 4 over 8 reduce to? 1/2. Divide both by 4, you get 1/2. What does 2 over 8 reduce to? 1/4. And then again, put the x behind it, put the x on top. I don't care which one you do. They're both just fine for me. If you want to keep the x on top, it would look like that. Okay, so one or the other. You do not need to give me both of those. Yes, Brody.
Can it be like a plus sign instead of a minus sign, you just have a negative?
You could do plus a negative. I think minus is simpler. But yeah, technically, it is plus a negative. Questions on that? Okay, on to the next thing. I want the simplified form. Notice all 4 of these. What are you distributing?
A negative.
A negative sign. Okay, but let's think about what that means. If there is a negative out in front, the number that you're actually distributing is what number? -1, okay? So you're gonna take a -1 and multiply it by everything. So this becomes what?
Negative 2 plus 3.
-2y, and then a -1 and a -3x. You're multiplying 2 negatives. 2 negatives multiplied together become a positive 3x. So this is your simplified form. -2y plus 3x. Okay, so I want you to do B, and I want you to do C right now. No, B and D. Do B and D. B and D. Give it a go.
Great.
What did you get for B?
X minus
X.
X, right? So a negative times a negative x is a positive x. Minus a negative is plus a positive, okay? So a positive x, and then distribute here. This is plus a negative 31. Well, that is a real goofy way to write it, right? So if it's plus a negative, it's essentially just x minus 31. So this would be how to write it. What'd you get for D? Plus 9n. Okay, so -6 or negative times 6m is a -6m. A negative times a negative, again, is plus a positive. So that's plus 9n. Okay, we're all going to take our time on this, right? And do it the right way the first time.
Course.
Yes.
For B, I put negative 1x plus negative
For B, you put, say it one more time.
1. Negative 1x plus negative 1.
Okay, so this is a negative 1 times a negative 1x. So negative 1 times negative 1 is a positive 1. So if you wrote 1x plus a negative 31, I would give you that. But you can't leave this x a negative because you have a negative times a negative, which is positive. Does that make sense?
Yeah.
Okay. Okay. Any questions on that? Okay, it's going to look like we're not doing the distributive property anymore, but you are still going to be kind of doing the distributive property moving forward. So just keep that in mind. Was that a hand up? Or can you charge your AirPods? I mean, you can plug them in. Yeah. Okay, like terms. Now, I assume this is something you've heard before you got to my class, like terms, right? Like terms are terms that have the same variable. Oh, I changed this and I didn't change it. It could be variables, right? Could put an S there. Raised to the same power. Okay, like terms have the same variable raised to the same power. So it would be like 6x squared y plus 4x squared y. If these are not identical, then they are not like terms. Okay? The numbers don't have to be the same, but the variables and their powers have to match up perfectly. Okay? You with me back there? Yeah. So that's like terms. Coefficient. Do you know what a coefficient is?
Heard of it.
Is that like the number being distributed?
It's okay, the number being distributed partially at times. It looks like that. Khalees.
Isn't it the number that we put with the y or the letter?
The variable, right? Yes, it's the number that comes right in front of the variable. So it's not the one that's being distributed, but sometimes it is that number. I'll show you in a minute. So it is the number in front of a variable. Okay, so for instance, the coefficient here is a 6 and a 4. Okay, coefficient, it's that number that comes in front. Do you know what a constant is? Constant is a number without a variable. So if you have like x squared plus 2x plus 5, which one is a constant? The 5, okay? This is your constant. So using all that information, we're going to be simplifying using like terms with a bunch of different setups here. Let's talk about this. Okay, so I'm going to show you on this first one how this is technically the distributive property. What you're doing here, this is 8x squared plus 2x squared. Mathematically, the concept is this. You are doing 8 plus 2 with an x squared, right? So I just reversed the distributive property. I pulled the x squared out of it and added the two things. Well, now 8 plus 2, we know it's what? 10. So this becomes 10x squared. So that's the distributive property, just in reverse of how you're used to it, right? They would normally give it to you like this, and you would turn it into that. Well, when they're like terms, we can actually combine those things. So we just simplify as much as we can. Okay, look at letter B. I'm going to color code here just for reference sake. Do you see any like terms?
Yeah.
What?
5 and 3, negative.
5x, don't forget your variables, and negative, I like how you said that, Shane, negative 3x. Okay, those are like terms. Do you see any other like terms here?
Negative 3 and 4.
Negative 3 and positive 4. Okay, so all we're left with is a 6y. There is no like term, God bless you, to your 6y. Okay, now here's an option. I don't require this, but here is one option for you. If you prefer to see your like terms together, then you could rewrite your problem right now. You could say 5x minus 3x plus 6y minus 3 plus 4. Okay, put your like terms together and then do the math. If you struggle at all with this, I would absolutely do that. Okay, here's what I need you to see. This is a negative 3, right? So we treat it like a negative 3. But a lot of times people see that negative 3 and they go, oh, I got to get rid of the negative 3, so I'm going to add 3 to everything. And then they end up adding a 3 right here. That is wrong. Okay, you can't do that because we're on the same side of our equal sign. You do that if you're going to move it to the other side of the equal sign. We're not. We're simplifying on that one side of our equal sign. So what we do is we go 5x minus 3x is 2x plus 6y, which we can't do anything with. Then what? Plus 1. A negative 3 plus 4 is a positive 1. And this is your simplified answer. Does that make sense?
Yes.
Tell me to slow down if I go too fast, okay? Okay, so look at letter C. There is a lot going on here, and some of it might be like terms, and some of it might not be, and you got to figure out what is what. Yes, Khalees.
So if the end of the solve is we can't like actually solve it to get one number, why do we do that?
Because we want the most simplified version. Because if they said, what if x is 3 and y is 2? Do you really want to have to plug that into every single thing? Or do you just simplify it down to one simple problem and then you just plug it in one time? Right? So eventually, this is like a stepping stone, right? We're going to get to a place where we're going to be plugging things in, and we want it as simple as it can be before we start dropping things into those expressions, okay? Okay, take a look at this one. A negative, highlighter. A negative VW squared. Do you have a like term to that? The negative 3 VW squared, right? Okay, so those are like terms. Plus VW, do you have a like term? Nope. Minus V squared W plus 2 V squared W. Those are like terms also. Again, if you want to rewrite the problem, put your like terms together. So I could say, negative VW squared. What would come after that? Plus or minus? Minus this guy right here. Minus 3VW squared. Okay, then plus VW, that has no like terms, minus V squared W plus 2V squared W. Now you can simplify. So when we do that, this becomes what? What number is in front of that VW squared, this one? A negative 1, okay? So negative 1 minus 3 is a negative 4 VW squared. Then we have plus VW. Then we have minus V squared W plus 2V squared W. What does this become? Not negative. This is like a negative 1, and we are adding 2 to it. 1. Do you need the 1? No. So you can just write plus V squared W. If you put a 1 in there, I don't mark you wrong, but you don't need it. Okay? Okay. I want you to do D and F right now. Do D, do F, and then we'll chat about them. Yes, is your phone up there? Okay, letter D. What'd you get? 2y, right? 3y minus 1y is 2y. Letter F.
8y cubed. I got 35.
8y cubed.
Oh my god.
8y cubed z minus 6yz cubed, right? So this is the same as this. And you are adding 7 plus 1, so that's 8y cubed z minus 6yz cubed. Why are those not like terms? They have the same variables and they have the same exponent.
Not in the same order.
Not at the same place, right? You are taking the exponent to the z here. You're taking the exponent to the y here. You cannot combine those. Okay? Yeah.
So like basically with all these problems, we're not like doing anything with that.
Right. You won't add them. You won't multiply them. It's just if they're the same, they become the same coefficient. Your coefficients become the sum or difference of what they would be. But the variables and the exponents stay put. Okay. So with that in mind, look at this rectangle. How do you find the area of a rectangle?
Based on height.
Base times height. Base times height, right? Area equals base times height. So if they asked you to write an expression for the area of this rectangle, you would do what?
7 distribute to x plus 3.
Right, 7 parentheses 2x plus 3. So your simplest version of the area of this rectangle would be the area equals what? 14x plus 21. Okay?
Is this third period already?
What?
Is this third period?
Yeah.
What time is it in?
I don't know. Are you coming to fix my thing? You can do it right now if you want. Doesn't bother me.
Can I hold out here or no?
Yeah, if you unplug it.
I'll just come back in a minute. We'll just sit there.
Well, so it's wobbling this way, and I think it's just these guys need tightening maybe.
Okay.
And then this whole thing lifts off because all the screws came out, but that's less of an issue. This is more what's driving me nuts.
Check it when you break. What time
Okay.
it stops over?
In 8 minutes.
8 minutes,
You
yeah.
guys know that like harder. That's not.
Thanks, Mr. Matt. Okay. Last thing is nothing new other than the quantity of what you're doing, but you are distributing and you are combining like terms. Okay, so I'm gonna show you the first one. I'm gonna have you try the next ones and we'll go from there. So first thing you do on a problem that has the distributive property typically is you distribute. Okay, so we're gonna distribute both things here. We're gonna distribute to get 3x plus what? 12, good. And then we're gonna distribute right here. So you get plus 10x plus 4. Okay, and hear me guys. The thing that gets done wrong the most on these problems is people rush through this and they go 10x plus 2 because they just forget to distribute it. And I know you know that. So don't do it the wrong way. I know you know that it has to go to both. Okay, make it go to both. Okay, so from here, find your like terms. 3x plus 10x equals
13x.
13x. 12 plus 4 equals
16.
a positive 16. So plus 16, and you're done. Isn't that lovely? So lovely. Okay, you do B and C. And when you're done with those, check your answers up here against mine. And if you got them right, you may start working on your homework. And if you didn't, I'll talk you through them in just a minute. There's your answers. Check them, and then we'll go over.
Oh no.
Did you get them right? Not quite there yet?
Why does it say or on the first one?
Well, because technically you could write it either way. This is the preferred. We usually put it in descending order of exponents. And the constant is usually the end of your expression, but I wouldn't mark it wrong if you wrote it the other way. All right, let me talk you through this. If you got these both correct, you can ignore me from here on out because you're there. If you didn't, here's what you're doing. 5 times 5 is 25, plus 5 times t is 5t. Okay, now you're distributing a negative. Negative 3t. And negative 3 times negative 6 is a positive 18, right? A negative times a negative is a positive. That's what we did on Friday, guys. Then you combine like terms. So you have 5t minus 3t is 2t. And then you have 25 plus 18 is a positive 43. Okay, so you can write it like that, or if you did the 25 and 18 first and you put the 43 first, that's okay. Either one of those is great. Any questions on that one? Okay, last one. We're going 3 times 2n is what? 6n. 3 times a negative 7 is a negative 21. Plus 7 times 4 is 28. 7 times a negative 2n is a negative 14n. Now, here's where I see some other mistakes. When we combine like terms here, this is 6n plus or minus. (6n) minus, right? Keep the sign in front of the number. So 6n minus 14n, that's a negative 8n. Your next one then, negative 21, not 21, right? You got to keep the sign in front. Negative 21 plus 28 is a positive 7, and that is your answer. Questions on that? Okay. Yes, ma'am.
I did that. I did like 6 plus negative 14.
That's okay.